All right. Before we start the show, our pop quiz brought to you by Mike Driscoll, Python author extraordinaire, many times over published. Publishes these quizzes every so often, and he's a pretty prolific guy. This one is number 90, listinsertion.py. So these things are always nice. They're always kind of succinct. It's rare he's got you doing large blobs of code. More often than not, he doesn't go beyond like 4 lines or so. So picking through this, he always finds like funny little tricky thing to demonstrate, some window of opportunity in the code or boundaries or whatever. So there's more to meet the eye on these things. So let's get into it. All right, my list. So we are establishing a variable in my list, and we are passing it the result of the string Python passed to the list function. So I'm pretty certain that basically would just return a list of all the characters.
Mm-hmm.
I don't know exactly how that one operates, but it's Python. It's usually pretty straightforward. And Tanif says, So in any case, we've got that list now. It has Python in it in some fashion. And we're adding parameters 100 and then the string bang or exclamation point, whatever. So then presumably the first position there, the 100, that must be like a position thing. But let's see. Let's look that up real quick. Lists, insert Python parameters. So yeah, first one's position, second one's element. So I think it's pretty safe to say that the list that we created is not 100 positions long, right? It's probably more like 6. Or since we started 0, it goes to 5.
Mm-hmm.
So then I guess the question is, does insert break when we give it a position that's way longer or way higher than the thing? Or does it...
Another way of looking at that is that 100, does it mean before position 100, at position 100, or after position 100?
Ooh, that's a good one.
Wow.
I guess it does beg follow-on testing of what insert does. So obviously it'd be more interesting if we did something in the, say, 0 to 6 range or something like that.
Mm-hmm.
Do 0, does it put it before, or does it replace it, or does it put it after, or something like that? But in any case, we're trying to figure out what's going to go on with that. So does anyone like to wager a guess? If you've got a guess, feel free to shout it out or put it in the chat. Got 4 answers here. Bobby E says A. Anyone knows he's a veteran and usually knows what's going on with these things. Is it a syntax error because the position is well beyond the end of that list we made just by putting Python into list function?
But that wouldn't be a syntax error.
Well, maybe the position was supposed to be second or something like that. It's not. It's proper. But yeah, so Robert obviously says not that one. So would it then be an index error, which I guess is closer to what I was sort of thrusting at, which is, we only have 6 positions in there, so I don't know. That's my vote if it's not the first one. And then D, I don't know if D makes any sense, because if it's 100, there's no reason it should be at the lowest possible position. So that's just absurdity. Anyway, so let's swap over to our screen where I've got this loaded up. Unfortunately, DN is out for this week, but he likes to use this website. I think it's called Python Tutor or something like that. But it has a really nice visual breakdown of running through a script and what happens, like memory registers, and has nice UI for kind of stepping through a thing. But I don't have anything lined up for that, so show up in the future, he does a better job of explaining these things. But anyway, I've got to type out my list equals list Python, my list insert 100, blah, print my list. Robert says it's A, just Python with the bang at the end. Oh, and he's right. Robert's always right. Just pay attention to this guy. All right, but he brought up an interesting point, which is, all right, so what if we did it at a more interesting position than one that's just like way outside or like way beyond the length of the thing? So like 1, for example. Now, is it a replacement or is it a, let's see, we'll put an M in there. So then, is that going to be like a push, basically? Pushes it to that register and then pushes all the rest down? Or does it replace it? Seems like it pushes them down. Or up? I don't know. Does that do it for you, Robert?
So you can also do this. You can just do help list.insert.
Ooh. Wait.
In parentheses. List.insert, close parentheses. You're passing list.insert to the help function.
To do something.
You're passing the method list.insert, so there's no parentheses after insert, right? It's just INCT, right, like that. And that gives you the definition.
Okay. Index object.
It's insert object before index.
Oh, there we go. Nice. That's how you use help docs, people. Help function. Now, how do I get out of here? Exit?
Press Q. Press Q.
It's either Q or escape, one or the other.
I think you could try either one.
Q? Oh, I'm in Vim or whatever. Yeah, Q bang or whatever. There we go.
Oh,
Yeah.
All right,
wow.
cool.
Okay.
Good times. All right, well, back to the rest of the thing. Robert gets another brownie point for always getting these right. And we probably don't need the elevator music going forward. Oh, no, I'm going to delete that. There we go.
Do you have Jeopardy music?
It was like the lo-fi beats thing, but it was to do nothing to. All right, good work, everyone. The quiz was popped. Robert wins again. Right before we get started, start with a joke. Why did the programmer quit his job? Because he didn't get a raise. Insert joke. Welcome, everyone. It is the 3rd edition of California Python. Since our rebrand, it's August 7th. It's 2025, people. Our speaker for the month is a fine gentleman I met recently through the good Dr. Tanim Islam. Goes by the name of Greg Tanaka, and he brings us prompt-driven development, a just full-stack product that I believe has pretty much flown straight from his brain to the internet. And thankfully, he's perched here at CalPy for however long he'd like to talk about it. But we had a good combo last night going through our notes, and I'm really excited to see where the conversation goes tonight. So, Greg, I'm going to drop the share and hand it off to you. Thanks again for coming. We are very honored to have you.
Okay, well, first of all, thank you guys at CalPy for putting this on and sharing information. Yeah, so I'd like to share kind of a project I've been working on. Again, I want to keep this interactive, so please, chime in whenever you want. We have a small group, so it's going to be easy to do that. So let me share my screen. I have a really short presentation, like it's just a few minutes. And then I have a demo, and then I have to have white papers. I could go pretty deep on this topic, depending on kind of the audience and what you guys are thinking. Yeah, so just kind of quickly introduce myself, Greg Tanaka. So basically, the effort we're doing here is something called prompt-driven development. And the basic idea is that we're trying to make prompts a programming language. This is a recent presentation that Stanford professor Andrew Ng did, where he showed that for prototypes, like, have any of you guys ever used Lovable or Replit or any of these kind of like tools out there?
Cursor?
Well, Cursor is kind of similar, yeah. But Cursor is probably a little step above Lovable. But these tools, like Cursor, for instance, are great at building prototypes. I mean, they're like hackathons, demoware. It's like amazing. You could build so much in just a few prompts. But the thing he observed was, while prototypes you get this amazing 10x improvement, maybe 100x even. For real code, not the same, right? You try using Cursor or Cloud Code on these large code bases, and they just kind of fall apart. And I guess I'll love to get people's reaction to this. I mean, is this something that you guys see yourselves, or actually, how many people here actually use any of the agentic AI coding tools?
Yeah, we've been using it.
You've been using okay. So Robert and Nathan, what's your experience been in terms of?
Yeah, it's right in line with what Andrew says. I know they're next week. Next week they're having the rapid engineering contest down in Menlo Park.
They're having a what again?
Rapid engineering contest.
Rapid engineering contest. Okay, I didn't hear about that. Okay, in Menlo Park. I live in Palo Alto, so I should mosey over to the. Can you tell me what day is that, and I'll try to check it out.
The 16th.
16th of August.
Yeah, I think. I mean, they're already full, but they're gonna live stream it.
Okay. Well, and then Robert, what's your experience been like using these kind of agentic coders?
I use the tools like Claude in the browser, right? So I just have it, give it a prompt, and I have it generate code.
Yeah.
And that way you run out of the context window, right?
Yeah.
Or for anything significant, you run out of context window.
Yeah. Easily. Yeah, it doesn't take much to run out.
Right. In Cursor, it does tend to break down for larger projects. I haven't actually tried using Claude Code from the command line yet.
Yeah, of all of them, I'd probably say Cloud Code's the best. But the issue is it's almost like throwing a grenade in the code base. You're not sure what's going to change, what's going to add, what's going to delete, what's going to duplicate, right? That's a big problem. And so the kind of benefits you get for larger code bases, like real code bases, is much, much less. In fact, some people say is one step forward, two steps backwards. So this is the problem that prompt-driven development is trying to solve. Is this problem is that, for vibe coding, demoware, stuff like that, awesome. For production code, it's a little bit more touch and go, right? It's only, I would argue some improvement, but some people would argue there's no improvement. But I actually think there's some improvement. So for those of you that are not familiar with like Cursor, it's basically a fork of VS Code. This is actually a picture of Cursor right here. And, you have the code here. It's kind of the center thing, very much like VS Code. And they add this kind of like prompt section. So these traditional agentic IDEs, they treat code as a source of truth. And the prompt, basically what's going on is it's just essentially patching the code, right? So the prompt, you could think of it as like a fancy edit to the code base. That's essentially what's going on, right? So do any of you guys out there ever program in C? I know we're a Python user group, but does anyone ever program in C?
Yep, a little bit. Arduino.
Okay, Arduino, yeah. So in C, can you imagine the analogy in C would be this? You generate some code, right? Some assembly, and then you're patching the assembly. So rather than changing the C file, you're basically patching, the assembly code, right? So nobody does that, right? Basically in C, you just recompile and you regenerate the assembly. No one sits there and patches assembly, right? It doesn't make sense, right? Maybe a long time ago, but certainly not now. But all these agentic coding tools, whether it's Cloud Code, Cursor, or Windsurf, RuCode, and there's like 100 of these coding tools out there. All of them are basically fancy code patchers. They're basically patching the code. You write a prompt and they'll patch a code. You write another prompt, it patches the code, right? Does that make sense? None of them treat prompts as a programming language. So for demoware, it's awesome. This works well. But any of you guys who've done any serious amount of programming or software engineering knows that by patching the code like crazy, and that's what these things are doing, they're patching the code with kind of partial information. It's like building a house on sand. The house is like really like kind of shaky, right? And so that's kind of like the big issue. And that's why these agentic coding tools haven't done as much help in these enterprise kind of code bases as you would hope.
When you say patch, can you explain what you mean by patching the code?
Yeah, so like in Cursor, you have the prompt over here on the side. You can say, I want you to fix this issue. I want you to do this or that. And what it will do is it will agentically go to different parts of the code files and make insertions, deletions. It would edit a bunch of files to accomplish your prompt. That's essentially what it's doing. So it's a multi-file edit, right? So it's like you can think of it like a super macro. It's like a super macro that will edit many different files, create new files, delete files, it'll do a bunch of different things. But essentially, it's patching the code base. That's essentially what it's doing.
It's performing diffs on the code base.
And performing diffs on the code base, yeah. Wait, and then maybe if your code base was blank, then maybe the initial prompt will create some files, but every subsequent prompt is a patch essentially to the code base. So your code base is a series of patch with the prompts. And for me, over the past 3.5, 4 years, I've been doing a lot of kind of AI development consulting, right? So I've done like over 300 projects, right? For like demoware, hackathons, awesome solution for real serious projects, for real projects. We kind of took a page from Andrej Karpathy. So for those of you guys aren't in AI, Andrej Karpathy is like a luminary, former Stanford lecturer, I think, director of engineering at Tesla, a bunch of other cool stuff, OpenAI. And he has this viral tweet that the hardest new programming language is English, right? And so we're kind of using that as our North Star, so to speak. And we're literally making prompts a programming language. So we're flipping the script. So rather than like here where the code is the main focus and the main character and the prompt is the sidekick, we basically elevate the code to become a programming language. We're not using prompts as a patcher, right? We're using prompts very much the way it works with C, right? So the way C works is you have these .c files and then it generates assembly. And as a C programmer, you may never ever look at the assembly code. In fact, it's rarely do you look at assembly code, right? And never do you actually patch it, right? That's just like nobody would ever do that. So we're saying, well, look, it's a very common paradigm to just regenerate, like very much as C. So if, for instance, if the compiler is good enough, why do you have to look at or patch the assembly code, right? And as interpreters got good enough, like in Python, why do you need to look at the interpreted assembly? It makes no sense. And as an LLM's good enough, why do you need to look at the Python in a JavaScript, right? So we're basically operating at a higher level of abstraction where you're programming essentially in English, okay? But we're treating it as a programming language, not as a patcher. And this is where a lot of people confuse prompt-driven development with vibe coding. Vibe coding is basically you're just treating the prompts as a patcher to the code base. With prompt-driven development, you're moving at one level higher and you're treating it as the source of truth, as the programming language. And it's following very much like the C paradigm where you're just compiling it down to Python or JavaScript or your favorite language. Does that make sense?
Mm-hmm.
Okay. Some of you might be thinking like, well, it sounds like kind of obvious idea. Why aren't people doing that? So why don't you think people are doing this today? Anyone want to take guesses? Anyone? Well, why do you? Let's go ahead.
It doesn't seem like you're guaranteed the same result every time.
Yes. Nathan hit the nail on the head. If you take a prompt and you generate code, so anyone that's taken code and generated through Cursor, ChatGPT, Sonnet 4, whatever your favorite LLM tool is, it will be different every single time. Even if you set the temperature down to 0, if you take a prompt and you generate code 20 times, it'll be different 20 times. Literally different every single time, right? So as a programmer, as a software engineer, it's really hard to build on something that's not deterministic, right? It's changing all the time. So it's crazy hard. And so this is the reason why people don't use prompts as a programming language, is because it's this non-determinism, right? So how do we solve it? So a long time ago, I was a chip designer. So my claim to fame is long time ago, I designed the very first commercially successful GPU. So any of you guys out there who ever used the Verge chip, that was my chip. It was the only viable commercially successful GPU at the time. It paid for all these big buildings on San Thomas and Santa Clara. And at that time, people were transitioning from using RTL as a source of truth for chip design to using, they're transitioning from using netlist as a source of truth to using RTL. So are any of you guys, anyone here have background in chip design?
Yeah, I was an IC designer.
Okay. So ASIC designer like me. So I was an ASIC designer. And in chip design, the traditional way of designing chips, digital gates, was through something called schematic capture, and basically a netlist. Basically, you would connect wires up from one, like let's say an N to a NOR gate or to an AND gate or whatever, right? So you have these wires being connected up and use schematics to do this, right? And then the world started transitioning to RTL using what's called registered transfer level, using languages like Verilog and VHDL. And so, Nathan, if you took RTL and you resynthesized it, right? What do you notice about the netlist, right? The netlist, is it the same every single time you resynthesize?
Yeah, it's been a while. I mean, they tended to be fairly close.
They tend to be close, but not exactly the same.
Not
So they
exactly.
kind of are functionally equivalent, but they're different every time. And the reason why is because the RTL is a abstraction of the netlist. It doesn't have the same amount of detail, so it can't connect every single wire. It's close, but every time you resynthesize, the netlist is different, right? So in chip design, this is a big freaking deal. Okay, for those who aren't familiar with chip design, chips have to be absolutely perfect. There cannot be a single flaw. There cannot be a single wire, a single gate that's wrong. If it's wrong, the chip is useless. So they spend balls of time and energy and money verifying these chips because every mask is like $100 million. These are crazy expensive to, like, for us software folks. A bug in the code, just send a patch of it, upload a new binary to the cloud, no big deal, right? But for chips, you cannot have a single mistake. It cannot have a single error, right? It has to be perfect. And so if you think there's a determinism problem with prompts, right? It's nothing compared to chip design. For chip design, it is, the toleration for errors is so much higher in terms of you have to be absolutely perfect. Every single billions and billions of transistors have to be absolutely perfect. So it's a much harder problem for chip design. But if you look at today, people doing chip design like NVIDIA, Intel, anyone that's doing chip, any sort of chip, even FPGAs, like smaller chips, they all use RTL. And the reason why is because there's just too many transistors. You can't possibly design all these transistors schematic by schematic by wiring every single wire up. It would just take you forever. You just could not do it. So, as I was doing all this kind of consulting for the 3.5, 4 years, it dawned on me like, well, yeah, sure, these prompts also suffer from the same issue that RTL or like VHDL or Verilog suffer going to netlist, right? Every time is like rolling the die. It's different every single time. But I was at Synopsys for 7 years, and we solved the problem, right? Synopsys today is like $100 billion company, right? It's the leader, number one company in chip design software, right? So they're solving this tough problem, making these complicated. Pretty much every company in the world uses Synopsys, and their claim to fame was basically having this rock solid methodology going from RTL to netlist, right? And I basically used a lot of that kind of methodologies, those ideas, those learnings that we did at Synopsys to handle this indeterminism that you get of generating these netlists from RTL for prompts. Because prompts fundamentally are the same thing. Prompts are a higher level of abstraction. And it's not like Python. Like so far in programming and software, it's always been a one-to-one relationship. For C to assembly, if you compile like 5 times, it's pretty much going to be the same thing, right? Almost identical code, right? Python to interpretation, pretty much going to be the same way every single time. But this is the first time, kind of like what chip design discovered, where RTL to netlist different every single freaking time, right? So how do you handle that, right? So basically, all the kind of things that we did, all the craziness, we had all these crazy tools and technologies to handle this issue, right? I basically this is what prompt-driven development is, PDD, the tool. This is what it does. It handles all those craziness, right? And makes prompts deterministic, very much like the way you would expect C to assembly to be, right? You expect so that you could trust. You don't have to like do open heart surgery to look at the assembly and figure out, oh man, is it working or do I have to edit this? No. You could just trust. You could program at a prompt level, right? You could program at a higher level of abstraction, right? Does anyone have any questions? It's kind of a big mind flip for most people.
Yeah. Well,
That's
we love
good.
all the lore. Thanks for the background on all this.
Yeah, sure. Robert, did you want to say something?
Yeah, that makes a huge amount of sense. That's actually something that's a problem that we're looking at for our idea.
Yeah, it's an incredibly contrarian idea. 99.999% of the people in the world don't do it like this. They, you look at the billions of dollars being invested in this area, pretty much is all investing in code patchers, right? Cursor, Cloud Code. I mean, even in the name, Cloud Code, code is the focus, right? It's not Cloud Prompt, it's Cloud Code, right? Codex from OpenAI isn't prompt X, it's code X, right? Because code is the focus, right? It's a huge mind flip for people because it's basically the next level of abstraction, but people aren't even thinking like this, right? It's like we're programming in English at a higher level of abstraction. And this project's open source. You guys could try it. It's on PyPy. I think the link was already sent out to you guys. You guys could use it right now. It's free to use.
It's in the
And
chat as well.
it's in the chat. Yep. And I actually used PDD to build itself, right? So are you guys familiar with GCC, like GNU C compiler?
Yep.
Okay. So one thing that GCC is really famous for, you could use it to compile itself, right? So it's really cool, right? It's like one of the few tools you could do that. PDD is the same thing. So you could delete all the Python files, and then I could regenerate all of them again, working using PDD. So PDD was actually built using itself, right? So I had the same kind of GNU C compiler approach. And yeah, so that's how I know it works, right? And in fact, it's so good that, like I mentioned, I do a lot of kind of AI consulting projects. The last 50 projects I used it, right? And have customers ask me, how'd you do it so fast, right? So it's been my kind of like secret weapon to be incredibly productive because like people are really fast for these vibe coding, for these hackathons, for these demoware, for these things that are just, visually kind of cool, but they're like very shallow. But for real projects, Lovable, Replit, Emergent, all these kind of like vibe coding tools really just fall apart, right? You start running to where you walk one step forward, you walk two steps backwards. It starts causing more bugs than it's fixing. With prompt-driven development, essentially, it is deterministic. So it really kicks ass much more at bigger code bases than smaller code bases because at smaller code bases, you could probably get away with vibe coding, and using prompt-driven development is probably too much overhead. But for large code bases, this is like you need determinism. You can't have it just randomly replicating code, right? You can't have that grenade in the code base where you're not sure what it's going to do. You can't have this kind of randomness, right? So that is prompt-driven development. I have a little demo here. I'm going to show it to you guys now. Let's see. Let me switch screens here. And then I'll show you. Then I'll show you guys kind of a big use case for us, right? Okay, so let me share my screen. Okay, I'm almost scared to do live demos because I don't know if this is going to work or not. So hopefully I didn't. I've been doing some development, so I'm hoping I'm not going to screw up this thing. Hopefully it still works. So I didn't. I was in meetings all day today, so I didn't get a chance to actually test it. So I hope it doesn't crash today, but we'll find out. Okay, so I have this prompt here. Okay, create a single HTML file that uses the camera to draw with an index finger, to erase with my palm, and then to select colors with a peace sign, okay? So I'm going to try, this is the prompt. I'm going to take this prompt and I'm going to do a head-to-head comparison with Cloud Code. So this is with Cloud Code. For those of you guys don't know, Cloud Code is probably the number one agentic coding tool, right? It's better than Cursor, it's better than Windsurf. I think it's the best one out there. So I'm going to take this, we're going to do a head-to-head comparison here. I'm going to copy this and I'm going to paste it into Cloud Code. And we're going to vibe code here with Cloud Code, okay? I'm not going to look at it. And then I'm going to do the same thing with, this is in a prompt file called handpaint_html.prompt. So just like in C or Python, you program in .py or .c, right? You program here in .prompt, right? So you program here in a .prompt format. And I have a special format where basically the underscore thing before the .prompt is the output file. So for every prompt file, there's a corresponding output file. Like it's a one-to-one relationship. It's not like Cursor or Cloud Code where you're not sure how many files it's going to create, whether it's going to be 10 files or one file. You're not sure. In prompt-driven development, the philosophy is it's very much like C. For every .c, there's a .obj, right? So it's very similar kind of philosophy, one-to-one relationship. Okay, so we're going to kick off the demo real quick. So I'm going to kick off here. I'll kick off Cloud Code first, and then I'm going to click off PDD. I hope it works. Okay, it's kicking off. Okay, great. Okay, so as it runs, I'll explain what's going on. So the prompt is the source of truth here. Let me try and make it a little bit bigger so that's easier for you to guys see. Okay, so this is right now it's compiling this prompt file. It just finished running the auto depths file, and then it's generating now the HTML file, the code file here. after it finishes the HTML file, it will generate the example file. So the example file is almost like a header file in C, right? So there's a context window, right? All these elements have something called a context window, and there's a limited amount of space you have in the context window. And so we use examples because it's a lot smaller, right? Okay, yeah, so it did auto depth. So as you saw, it basically it knows that it needs to use the media pipe, so it inserted that into the file here, and then it generated the file, so it finished that, and now it's running crash. If it runs the example, which is kind of like a header file to make sure that everything runs, and then after that, it would run verify to make sure that actually the output is consistent, and then after that, it will generate test or generate the unit test. So we use also firmware verification. We use the Z3 library from Microsoft, and after that, it will run fix, which will just verify that all the tests pass. So it runs through all of these different commands. Yeah, so this will run for a bit. What you'll see at the end, though, is that it will update this prompt file. It'll be a lot more detailed. So I'll show you. So you can see, like, we started with kind of like a single line prompt, and now you can see it's like multiple. There's more detail, and it has this dependency in here. And then you'll see that after it updates the prompt file, it's even more detailed, right? So this is how we get determinism. Okay, yep. Okay, so you just saw the last was update, and so now you see here's the full fleshed out prompt file, right? Okay, so let's look at Cloud Code to see how it did. I need to open another shell here, so let me do that.
If I could interrupt for a second. So
Yeah.
this is the normal VS Code, but in the terminal,
Oh, this
you
is
have
Cursor.
Cloud
I'm using
Code.
Cursor. I'm using Cursor. Yeah, yeah. So
You're
that's
using
right.
Cursor.
Yeah, so this is Cursor, and I'm using Cloud Code inside of Cursor, and I'm using PD inside of Cursor. Correct. And Cursor is basically a fork of VS Code, except it has like this cool, chat agent here. Okay, so let me go to Cloud Code, and let's see. Let's open Paint. Let's see how Cloud Code did. Okay, so let's see here. Allow visiting the site. Yep, allow visit. Okay, let's see. Does it work? Okay, okay, I just loaded up the example that we generated with Cloud Code, right? Okay.
It says clear canvas, toggle camera.
Yeah. Yeah.
Oh.
Okay, so it kind of erases, although I can't see my eraser, so that's a bit of a problem.
Looks interactive. Okay.
Okay, yeah, it looks like I can select, so I can select different colors. Yep, I can select different colors. Okay, so the cursor did a decent job, except that I can't see my eraser here. So let me go back to Cloud Code and let me tell it to fix it.
Oh.
Okay, so it worked, but I can't see what is being erased. Okay, and then let me open up the output of this, which is in source, open and paint HTML. Okay, let me see how this did. Well, actually, before I do that, okay, it took about 1 minute and 42 seconds for it to generate, and total cost was 23 cents, right? Okay, so let me bring up hand paint, and let's see how this looks. Okay. Okay, so this is PDD, right?
Okay.
Okay, so it looks like it's good, right? It does that. It shows me the eraser, so it could show me erasing. And then can I select the colors? Let's see, does this work? Okay, yep. So okay. So it looks like PDD worked here, and I could erase. Yep. Okay, I could erase. Okay, that's all good. Okay, so Cloud Code just finished. Let's have it. Let's see how it did. Let me go back to refresh the screen. This is Cloud Code. Let's see if it fixed it.
Okay.
Okay, so let's try this now. Oh, let's see. Nope. Okay, well, it shows me the eraser now, but it's kind of okay. So let me go back and tell Cloud Code that I see the eraser now, but it leaves tracks.
Craig, my mind is blown. This is amazing.
Oh, thank you. Appreciate it. Thank you for the kind words. So we'll let Cloud Code go, and then let's see if it fixes it this time. And then maybe it's fixed. Okay, let's see how it looks now. Okay.
Right. So reload.
Reload.
Okay.
Oh, I can't see the eraser. Can I draw?
Okay.
So let me go back to Cloud Code and ask it to.
Ooh, can I add a feature?
Well, let's do the demo first, then we could go to town and stuff. Okay, so I don't see the eraser now. Can you please fix? Okay, so let's let it do that. In the meantime, if that's cooking, let me just show you guys the PyPy repo. Okay, so you could read more about prompt driven here, and you could do that. You could I have the hand paint demo, so you guys could do it yourself, use it yourself to play. And also, I have another one where the back of my shirt, you can't really see it, but you can make these fancy. Is it? Can you guys see it? It's like you can make your own fancy QR codes.
QR code.
Yeah, but okay. So let's see here.
Back.
Let's see here. Oh yeah, let me go to the homepage. Okay, so in the white paper, actually, let me show you guys show you. Well, okay, let's go to white paper here.
So you have your own Discord for PDD, right?
Yeah. Please join, guys. Everyone that's on, please join and tell me what you like and don't like. Tell me what could be better, what's what's good, what's bad. Please, please. Yeah. So basically, the concept with PDD is that, let me see, how do I shift this around? Okay, the concept with PDD is that the prompt is the source of truth. It's the programming language, right? And then it would generate the code base, right? And then, just like in C, there's like a .h file, like a header file, right? Which is kind of like contains a function signature. Same basic thing. So the examples we use is like a function signature. It's like how to use the module. And the reason why we do that is because the example could be a lot smaller than the code, right? The code may be 1,000 lines code, but the header file is going to be much smaller. So it's much more efficient for the context window of the LLM. And then we have all the unit tests. And then all the implementation learnings get fed back into the prompt, right? This is in contrast to what the current agentic coders do, which is, they patch, right? The basic patchers, the code patchers, the fancy code patchers, essentially, the patching. And, the first maybe 4 patches may be okay, but as you get to your 100th patch, it gets to be really screwed up. And this is why it doesn't work well for large, complex code bases. So, yeah, so kind of the flow here is like this, right? And I showed you guys in the little ASCII art thing, but basically, so you have your PRD, you will break that down to individual prompts, and these 2 colored boxes are the things that the engineer, the software engineer is responsible for, right? Is this just like you make sure your Python files are right, you make sure your prompts are right. So you got to actually read the prompt and edit it, right? And then AutoDeps will automatically figure out dependencies and insert them in, as I showed you guys. In the case with HandPaint, it put in the media pipe. And then once you do that, it will generate the code, right? It will generate the code. And then from there, you create an example, the header file, essentially. So it's like it's like how to use the code that was generated so that other modules could use it, token efficient, right? And then we run through a crash thing. We make sure that the example could actually run the generate, and it'll fix any crash involved. And then we run a verify that basically looks at the output of the example to make sure that it's functionally correct, that basically matches the spec, which is the prompt, right? And then we generate unit tests. And these unit tests aren't just an average unit test. We actually use the Z3 library to do formal verification. And then we run fix to make sure all the tests pass. And then after all that, we update the prompt again so that the prompt remains a source of truth, right? This is kind of a complex diagram. I don't know if that made sense to people.
I mean, I don't know if I could tell you exactly all of what you just told me blindfolded, but it made sense. It's quite the flow.
Okay, great. So now let's see if it finished. Let's see if Cloud Code got it working now. Let me just try this here. Okay. Okay, look, my eraser shows up right. Let's draw. Can I erase? Yep, I erase. Can I draw different color? Okay. So Cloud Code got it working now. So let's look at the benchmark and see how it compared. So let's exit out of Cloud Code. Oh shoot, I forgot. In my demo, Cloud Code they now take away the cost, so it doesn't show you the cost and how long it took. But okay, had it show it? Okay, I ruined my demo here. But okay, I forgot they changed it. So basically, Cloud Code used to tell how much money it consumed.
They said it in one of the previous gens. It was like 22 cents or something.
No, that was mine.
I see.
Yeah, shit. Okay, I wanted to show you mine because mine was a lot cheaper. That's why I wanted to show it to you. But unfortunately, I forgot that Cloud Code doesn't do that anymore. I think they got embarrassed because it was too much money. So, yeah. Okay, but anyways, okay. Had Cloud Code shown it, it would have showed it's a lot more expensive. And the reason why is because for these agentic coders, they only spend maybe 10% of the tokens that they generate or use to actually make code. Most of the tokens are used to manage what's going on, like read the file, look at this, look at that, stuff like that. It's not actually to generate the code. Versus Cloud Code, I mean, versus that's with like Cloud Code. Versus PDD, pretty much, you have full control of the context window, and it's pretty much all being used to generate code. So it's a lot more token efficient, so a lot more affordable, so to speak. And as you saw, it kind of one shot at it. Versus with Cloud Code, I had to play with it like 4 or 5 times, right? So so that's kind of a like demo one, like a really quick get up to speed type demo. Now let me show you guys kind of like the main use case of, or one of the big use cases of Cloud Code, I mean of prompt driven. Okay.
Now, one of the points seeming that you seem to imply in your white paper is that if you add more prompts, patches, patch-driven thing, it gets really tangled. So, what's the? Can you do a side-by-side comparison number of lines of the code that cloud generated versus
Yeah.
what?
Yeah. Let's see. So yeah. So let's see. It's different every time. So I'm not sure what this is going to say, but let's see how many lines of code this was. This was for prompt driven. It was 638 lines.
Okay.
Cloud Code. Let me see here.
You can do a WC-L of that HTML.
Yep, it's 456.
Okay.
Yeah. So let me show you guys the secret of how prompt-driven development works. So one of the secrets to it is we have this marketplace. So what happens is when you at this step here, when everything passes, basically at the last step when everything's working, we know it's working, it uploads the prompt and the code, the prompt code pair, as well as example, as well as the prompt to our cloud data. Not the open source version doesn't do that unless you sign up for PDD cloud. But for prompt driven development cloud, it's a lot more powerful because okay, let me back up a little bit. Are you guys familiar with that concept of few shot learning? Do you guys know what that is? There's two ways of training an LLM. One way of training an LLM is you basically adjust the weights and all that kind of stuff, right? I mean, when you're using the transformer and you're basically cycle throughing and doing pre and post training, all that stuff. The other way of doing it is what's called in context learning. So in context learning, basically, if you give an LLM an example, it will do a much better job than you don't give the example. The same thing with humans. If you give me an example, I'll do a much better job with that example than if I didn't have the example. In fact, you could take a less powerful LLM, give it an example, and it'll outperform a more powerful LLM. Right? So this is what they call few shot learning. So basically you give, like, let's say I wanted the LLM to write a poetry, right? I'll give the example of a poem, and it'll do a much better job writing a poem with that example. Or like in this case, when I wanted to generate code from a prompt, if I give it an example of maybe similar code, it'll do a much better job in generating code, like the code that you need, right? Does that make sense? It's a concept called few shot learning. Does it make sense to everyone?
Yeah.
Okay, great. Okay, so kind of the secret to prompt-driven development is that we have this marketplace. So basically, after this step here, it uploads it to the cloud, assuming you're on a cloud user. If you're not a cloud user, you're open source, and it doesn't happen. And then what happens is when you regenerate, okay, or when you generate, it basically has this few shot example. So it has this marketplace here, and so it could be your own example, it could be someone else's example, right? And of course, you can exclude it, right? So like, let's say it's something secret, you don't want other people to have it, you can exclude it. People can actually put a price on it, saying, oh, this is a little bit too big. Let me make it a little bit smaller so it's easier to see. You can put a price on it. So it's a little bit like an app store. So basically all these prompt examples are on there and you can use them for your generations. And by doing it, it makes the LMs a lot more deterministic and a lot more powerful. So we have this kind of few shot marketplace. And if, like, for instance, you don't like, so like if you don't want people to use it, you could exclude it. You could exclude others, or you can set certain pricing, or if you don't want to use other people's ones, you can also exclude them, right? You can say, well, I don't want this example or whatever example you want. You can also exclude it from being used in your generations, right? So we have this kind of few shot marketplace where basically people contribute and use each other's prompt code pairs, essentially, right? And that's kind of like what powers PDD and how we get very deterministic results. It's these few shot examples. So you can almost think of like eBay, but for code and prompts, essentially. So I'll talk about one of our big use cases. One of the big use cases is migrations. In fact, for those of you that don't know, C came out. One of the primary uses of C when it came out, the programming language C, was because people had different processors. There's 8086, there's MIPS, there's ARMs, there's all these, PowerPC, there's all these processors, and porting the assembly code between them was kind of a pain in the ass. So C was nice because you could retarget it, right? C was a higher level abstraction of the assembly code, and so it's easier to retarget to different processors. And just like with C, it's good for retargeting. Prompt-driven development is also really good for retargeting, right? So if you have, so basically what we have is you could let's say you're on Ruby on Rails and you're on let's say Heroku, right? And you're using MySQL, right? And it's currently a monolithic thing. You can you can you know let's say you want to go to Next.js, more modern front end frameworks, right? And you want to go, let's say, on Vercel, right, as an example, and you want to use the micro or the serverless, right? So it's not as expensive, right? And so you can put in your information about kind of like traffic patterns, like a lot during the day, and then what is your migration time frame, etc., right? um, and then like put all your information in, and um, and uh, so the example here, I can't show this live because it takes too long to run, but what I'm going to show you, the migration that we did here, is there's this is the website, but this is the Heroku getting started. So they have a repo here that shows how to use Heroku. I mean, use Ruby on Rails on Heroku, right?
Sure.
And this is the website, the website itself running, right? So what you would do is you would basically go here and you would copy the GitHub, and then so once you submit that other form I showed you earlier, you go here and you basically just drop in your GitHub repo link, right? And then you have to put your personal access token in here, right, so that we could access it. And then you put in your Sonnet 4 key, and then what framework you're trying to do, and then you run it. And then once you run it, basically, you can see it kind of running in progress now. You'll see this migration. It would automatically convert. So let's say you want to go from AWS to GCP or Ruby on Rails to Next.js. It will convert it automatically, right? So we basically take the existing code base, like you see here, and then we would abstract it to prompts. So it's a high level abstraction. And then we would target it to new architecture, and then regenerate all the code again, right? And that's what you see going on here. But it takes a while for it to run. So it's not a kind of a live fast demo. So, but anyways, you can see it run here. And then afterwards, when it's all done, it's a little bit like a cooking show, right? When it's all done, then it gives you a link to the fully migrated repo, and that's what I have here, right? Is the migrated repo, and it tells you, it will automatically generate all the instructions of how to run it, how to deploy it, all that kind of stuff, like all the migration. It joins all the tests, etc., right? And so I could show you kind of like the comparison between the Next.js version, which is this one here. You can see the little Next.js thing here, and then I could show you the Ruby on Rails one. So this is the original one right here. This is the original, and then the Next.js one is here. Okay, so it's pretty much pixel perfect, right? I mean, it's like if I didn't tell you which one, if you didn't see this Next.js, in fact, if I didn't see the Next.js, I don't know if I could tell which one's which. So so that's kind of like my kind of monologue so far, but of what prompt-driven development, like basically two key benefits of prompt-driven development. First is the determinism, right? So basically you can use it for large code bases. And the second one is performance. And so I'll show you guys some performance metrics you could see here. So like this is showing, well, like basically prompt-driven development is a lot more reliable than Cloud Code in general. And I can show you, like, what's also kind of neat is the performance. So let me show you some graphs here. And this is all in white paper, so you guys can look at it. But basically, like, the cost is a lot better. I mean, this is runtime cost because it's a lot more, because we're able to do architectural optimizations using prompt-driven development. You tend to get a higher success rate with prompt-driven versus Claude code. And you guys are working in benchmarking yourself. I'd love for you guys to upload your own benchmarks and
Yeah, absolutely.
either support or refute what I'm having here. So, but basically, that's kind of like what the kind of key benefit of prompt-driven development is, because you're working at a higher level of abstraction. You can see the forest between the trees, right? That's basically what's going on. So you can do a lot more architectural optimizations than you could otherwise. And that's why it works really well for these migrations, because you're able to up-level the code to the intent, right? The prompts capture the intent, and then you can basically retarget the architecture and take advantage of all the things that the architecture has. So, like for instance, Ruby on Rails is monolith, right? It doesn't have server-side rendering. Next.js has that. So when you migrate, they take advantage of all those kind of new technologies that didn't exist 15 years ago when Ruby on Rails first got started, right? But
So you can reverse engineer an existing code base into prompts that
Yes.
show basically the requirements.
basically shows you the intent, right? It basically shows you the intent. Yep. Yep. So that's kind of like one of the key benefits. In fact, when Synopsys got started, its big key benefit was being able to retarget at different technologies like TSMC versus UMC versus all these different process technologies, where you could take the same RTL code and then regenerate it for different process technology. So it's kind of natural why prompt-driven development is also really good for migrations. Very much the reason why C was good for migrations, going from MIPS to ARM to PowerPC to 8086 to whatever, right? It's the same basic idea, because you're at a higher level of abstraction. Yeah. So, guys, I love to. I talked enough. I could talk for hours, but I'd love to get questions, thoughts, feedback. What you like, what you don't like. I'd love for you guys to try it. It's open source, so try it, and join our Discord group to let me know what's like good, not good.
Do you have the link to the Discord somewhere?
Yeah, it's actually on the repo. So I think here, let's go back to that.
Well, I mean, I looked on the PDD CLI.
So here's the Discord right here. Right here, just click on this.
Oh, it's on the PyPy.
It's on the PyPy, yeah.
Okay, I thought looked at the GitHub.
Well, I should put it on the GitHub too. Thank you. That's a good suggestion.
This is why I get in trouble at work. I follow up with what people say.
Yeah. So
GitHub is a single source of truth.
Yes, I need to put it on there. Sorry, this is still very much a work in progress. So I guess I'll ask a question. What do you guys think about programming at the prompt level versus, let's say, the JavaScript or Python level?
Well, for me, it's a big problem because I work in a national lab, which equals nothing cloud. In fact, we don't even like.
You don't have to use my cloud. You can just use the open source version, which does not connect to the cloud. It's all.
They don't even really generally allow external non-phone homing LLMs because of the paranoia against malign weights in the LLM.
Right.
Well, you could actually use like OpenAI a few days ago released the open source, well, not open weight version of the model, and there's several other open source good coding models, so you can use that on your laptop. So it's no cloud, it's fully protected. So you can use that with Ollama. I support Ollama. I also support mainly Ollama. I also support MLX. If you have a Mac, you can use the MLX. Like local LLMs, so it's all secure.
Okay. Right. Well, what about an on-prem LLM at Livermore called LiveChat? Is there anything?
Yeah, you could use this with any LLM you want, actually. So any LLM that's supported by Light. I use a library called Light LLM. So as long as it's supported by Light LLM, you can use it.
Okay. Oh, interesting.
So there's like thousands of LLMs are supported. You can use a local LLM, right? And it's all on your computer. You can use it for free, right? Like my laptop has 128 gigabytes of memory, so I could support like a fairly decent LLM on my laptop.
Okay.
Can we add more features to your app?
Yeah, please do. Yeah, I mean.
No, you made the drawing thing. Can we add text?
Oh, that's a different thing. You guys could do that. So what I encourage you guys is, the example is in my GitHub repo. So go ahead, go to town, play with it, do whatever. Yeah, and please, yeah, and have others like I just showed you my T-shirt, right? My T-shirt hasn't. I think we haven't released yet, but we're releasing this example. We can generate.
Right.
It's can you guys see it says "make me a sandwich"? It's kind of a internet meme, but basically you could generate QR codes with pictures. Like this is a sandwich. So the example we have in there is make me a sandwich. So basically you can make a QR code with any URL link you want, with any image you want. And it kind of looks like it's like a beautiful, well, maybe not beautiful, but a QR code disguised as an image. So that's another example I have.
So what exactly does the QR code on your shirt take you to?
Oh,
It take you to
It takes you to an example of how to create a QR code with a picture with PDD.
Oh, okay. So it's the high level. It's the prompt for how to create a QR code.
Yeah, how to automatically create a QR code with an image. Yeah, yeah. So I have a few examples, and we're putting more in there. And so you guys, this is how to get started with PDD essentially.
Okay. All right. Well, I just joined the Discord.
Oh, thank you.
I don't know how. It looks like Woody did as well. All
Thank you,
right.
Woody. Yeah, I mean, I realize this is kind of a very contrarian idea, right? So it takes.
I'm new to the idea of using LLM. I use them to like clean up my language when I have to send an email out and I'm angry. And so it says my prompt is make this email diplomatic.
Okay, that's a good prompt to have, right?
While keeping the intent.
But like the prompt you have, right? I mean, that's kind of how I got started, is because I had all these great prompts I would use, but I like in Cursor or Cloud Code, they scroll away, so I have to go back and fish them out, right? And I thought, well, why am I not the real code is actually the prompt? Why am I letting this stuff scroll away, right?
Okay.
I wonder if embedding data into your prompt would be possible as well.
Yeah, okay, so let me show you how PDD is built, right? So this would give you guys some good insight. So in PDD, I have these Python files, which pretty much I never really look at. And then I have these prompt files. So there's two types of prompts. There are runtime prompts like _LM. These are like runtime prompts, right? So that's why you see the XML, like the heavy XML format, right? But I also have special XML tags like include. So include is equivalent to like the C include. So it basically includes this file essentially, right? And so I have a few special XML tags like this. I have shell, so it could run a shell command. I have like PDD, which is a comment. It comments out the text, right? I have web, which retrieves stuff from the web. So I have these specialized XML tags, but pretty much everything else is standard English. So, but this is a runtime prompt, which is different than a compile time prompt. So this is a prompt that generates code. Here, let me make this smaller, bigger, so you guys could see what I'm talking about. So the elements that you need to have in a prompt is you need to have what are the inputs, what are the outputs, and what is it supposed to do? That's you can do anything else, but you have to have at least those kind of basic things, right? And like I have a preamble here because like all my prompts generate kind of similar kind of code. So this preamble kind of tells it like kind of the stuff where things are and things like that. And then you have your inputs and outputs. This is how I handle dependencies, right? So when like this prompt here uses these code modules. So basically, these are like equivalent to C header files essentially. These are like C header files, and these are a fraction of the size of the actual code file, right? And then I use my README, the README through PDD as the spec essentially, right? And so it includes a spec. And so that's how it knows how to create this function, right? So this thing's like 44 lines of code, right? Let me show you the actual AutoDeps code file just as a comparison here. Okay. Oh, this is not that big. So it's 104. So it's not that much bigger. But sometimes I have code files that are like 10x the size of the prompt, right? So you can see the amount of time it saves you, right? And it's also a hell of a lot more readable, right? Versus like the actual code. I mean, yeah, some of you guys probably know Python really well, but in general, it's hard to understand other people's code, but it's easy to understand other people's prompt. So the other big advantage of prompt-driven development is it's easier for everyone to work together because they can read each other's code a lot easier, right? So basically, I kind of treat my PDD directory, my code directory, as kind of like as like my OBJ, the object files of C, right? May or may not actually look at it. In fact, I rarely look at it. I look at it mainly for demos like this to kind of show you guys what I'm talking about. But and then because the PDD is deterministic, right? I know exactly how many files it's going to create, right? Unlike Cloud Code, where I don't know how many files it's going to create. I don't even know the name of the file. So basically, I tend to use PDD as in makefiles, essentially. I'm not sure you guys are big makefile fans, but I use makefiles, right? So that's kind of the work style, right? So basically, you're coding in prompts, right? And I use Cursor, like I'm in Cursor right now, to help autocomplete the prompt, right? So I can write these prompts really, really quickly, which is kind of meta, right? So I'm using prompts to write prompts, right? Or I'm using AI to write prompts, which generates code. So it's like, doubly fast, right? It's like a double whammy. And then use makefiles because PD is deterministic. I know exactly what it's going to do every single time. So yeah, so that's I use PD to make itself essentially, and then it creates a bunch of test files, test cases. I can show you that. So one of the things about PDD philosophy is that you tack on. So if there's a bug, you create another test case for it. So PDD is reliable for several reasons. One of the reasons why it's reliable is because it has the few shot examples. Okay. The otherwise reason why it's reliable is because we have these test cases, and when there's a bug, you keep on tacking on test cases, right? And I use Cloud Code for that. Although PDD also does it. We also have a command called bug to fix as well, right? Yeah. So we use something called Z3, which is how many of you guys are familiar with the idea of formal verification?
A little bit.
No, but okay. Do you want to explain what formal verification is so that people know?
I mean, I've heard it's a way of verifying that your code is bug-free with this limited bit of functionality, but maybe that's a paraphrase.
No, it's essentially right. So basically, what we're using formal verification here is verifying functional equivalence. We're basically mathematically proving that the prompt and the code are the same, essentially, right? Now, the code every time you generate may be different, right? But functionally, it's the same. Does that make sense?
Yeah, all right.
Yeah. So there's a great library from Microsoft called Z3, which is a formal verification library. And so that's one of the key things. So when you look at the test we generate, they're very extensive, right? We really generate extensive tests because this is like the safety net to make sure that the prompts are reliable, that are deterministic, right? The code files may change, but because of the safety net, because of the few shot examples, it's very, very, it's like you could trust it like you can with C to an object code, right? So you could see how PDD works, right? So it has this kind of test harness, right? And it auto generates. So the prompt generates these extensive tests, like you saw here. It generates the code file. So you see, like this auto depth is like 104 lines. Let's see how big the auto depth example is.
A prompt that says a find command to find autodepths.
There you go. I need to do that. Okay, so here's autodepth's main.
Okay.
Oh, okay. Well, this is not that much cells. It's 46 lines. But anyways, it's smaller. So the reason why it matters is because all these LLMs have a token window. They have a certain context window. And you want to be very, you want to do what's called context engineering. You want to use the space of these LLMs really wisely, right? And so these examples, they tend to be smaller. This is not that much smaller, but a lot of times they're way small, like 1/10 the size. So they just show how to use it. And so it's a lot more token efficient because rather than having to know what inside of like auto depths, it just shows you how to use it, right? So other modules could use it and being token efficient. It doesn't like blast out the context window. And that's kind of the key thing of prompt-driven development is that you have precise control over the context window. With like Cursor or Cloud Code, you have no idea what's in that context window. No idea, right? And it can be different every time. In fact, it is different every time. You have no control, right? With prompt-driven development, you have precise control. You know exactly what's in the context window. And you can use the full context window because a lot of times Cursor especially, they tend to cheap out and they limit your context window. So you get this teeny tiny context window, even though the L is capable of a lot more.
Wow. Oh, okay.
Yeah, so you get incredible amount of control with prompt-driven development. It's like with PDD, it's like I'm trying to think of the analogy. Maybe like automatic versus manual car, right? With the manual, you could really control it. Like you could really control what gear you're in. You get a lot of like really precise control. And that's what you get with PDD. Is a lot of this is not meant for vibe coders. This is meant for programmers, right? Serious programmers designing serious projects.
I'm thinking of I've got some non-trivial GitHub projects that I use all the time.
Yeah, give it a shot, please.
The start would be load in this repository and load in all the.
If you want to do a migration, yeah, you could use it for migrations.
I was thinking adding functionality, but being informed by the code base that I have. Something basically for me, I described yesterday. I've got this unmaintained GUI code to set up credentialing for these various services. Can you incrementally create click-based or other TUI-based way to credential to do the same equivalent credentialing for these services? So incremental implementation or enhancement rather than from full cloth. That would be a value add rather than
give it a shot and let me know how it works and or doesn't work, right? And I'll try to fix it. But yeah, and so this is a totally different methodology, right? There's a lot that still needs to be discovered. It's a very new area. It's a different way of programming. And so I can't pretend I have all the answers. And that's why I love to talk to engineers like you guys to kind of see what you guys like and don't like. And you look at Python today, right? Python, 3.14 or whatever, compared to the initial Python, it's evolved, right? And I expect PDD to also evolve, right? But it's really users like you that help make this happen. I open sourced it so that people can add and contribute and tell me what they like and don't like. And so please, kind of chime in, tell me what worked, what doesn't work. And we're trying to figure out patterns that work well for this kind of prompt-driven methodology.
I'm curious about your formal verifier. Do you use different ones or just the one that you mentioned?
I'm kind of a Python guy, so I most of my stuff I want is in Python. I do also for the web, I use TypeScript and stuff. But yeah, this works best for Python. So you guys are lucky. It works best for you guys because you guys are Python users. The other stuff I haven't tested as much. So it works really well. I don't know if the other languages have a good formal verification library like Python does. So I'm not sure actually. I don't really play with the other ones as much as I do with Python.
So I'm curious, have you ever tried trying to create like an undecidable thing for your formal verifier to see if it...
Oh, I let the LM handle that. So I don't do it myself. I let the LM take the prompt and figure out the formal verification rules.
Well, I meant like if you're trying to formal verify, like you don't want to run into the halting problem or other undecidability things. So
yeah, for most part, it just works. So I haven't had to really mess with it too much.
All right.
It'd be interesting though to give it an unverifiable code and just see how it reacts to it, right?
You guys should try it. Let me know, right? See, you put it to its paces, right? I've used this on probably about 50 projects now. I love it. It's become my go-to tool. I'm hoping that it will become your guys' go-to tool. But there's a lot of rough edges and bugs and stuff like that needs to be fixed and improvements. And so I kind of need people using it to tell me what's good and not good about it.
Absolutely. This is exciting.
Yeah, thank you. Appreciate it. I predict in the future everyone's going to be doing prompt-driven development. I think it's so because these just a year ago, an LM generating 100 lines of good code was hard. So it had to be patcher. It had to be a patch, right? That's why Cursor and Cloud Code are patchers. But today you can do 1,000 lines of code pretty reliably, and maybe with GPT-5, 2,000 lines of code, right? And it's only going to get more and more reliable as time goes on. And so the whole idea that you have to be a code patcher versus doing it the way C does it, right? It'd be crazy to think of C we're going to patch our assembly code. What the hell? Just regenerate. What's the big deal, right? And so once the LMs become reliable and they could generate big enough context window, why would you ever think about patching your code, right? It's dangerous. It makes no sense. I
guess the gold standard would be using LLMs to create reliable kernel code.
Yes, yeah, one day, yes. So, but in chip design, RTL, you almost never want to do what's called an ECO, engineering change order, and patch the netlist. It's super dangerous. You do that as a last resort, but you try not to do that, right? But what's funny is traditionally it's very dangerous engineering to patch stuff. But what's interesting is with all these kind of agentic AI coding tools now, they are all like patchers, right? So they're kind of perpetuating this kind of patch thing, right? And so so I live here in Palo Alto and I added it onto my house. And I was like the owner builder and architect to build onto my house. But looking back on it, I walk around my house, I see all these mistakes, all these things that could have been better. I should have just bulldozed the whole house and built a new house. It would have been cheaper and faster and better. And the same thing with code bases, right? You could keep patching the code, but after a while it gets kind of twisted. And a lot of times it's better just to rewrite it from scratch right? It would be cleaner code, more efficient code, right? It doesn't have all the cruft of what you did before, right? And that's the same thing with prompt-driven development, is that you have a fresh foundation every single time. You don't have all this, Winchester House type of Winchester
Right.
House type of situation going on.
Yeah. Well, I mean, that would be the interesting thing, to infer a set of prompts. Migration looks like a great example.
Yeah, it's the biggest use case for it.
Code generates the implementation that you see.
Yeah.
My idea, also scientifically, is I have a mesh, a logical block structured mesh. Describe, have an LLM or whatever tool generate the code that generates that mesh in whatever language that is.
Yeah, give it a shot. Try it. I mean, I need people using it and trying it and trying to advance this method. This is almost like a religion. It's like a new type of religion, right? It's a new way of coding, right? I had someone who tried using this out, and he says, "Yeah, I feel like I'm learning to program again, right? Because it's a very different way of programming. It's at a higher level, right? So it's like it takes a different way of thinking."
I wonder how you transition. Like, there are going to be a lot of people building those demos and so on, and then throw it over the wall, and then you have to kind of pick it up and then maybe switch it to doing prompt-driven development. Have you thought about how that goes?
Yeah, and that's why we kind of focus on migrations, because I think for existing projects, people may be like, too much trouble to switch, right? But I think I would argue prompt-driven is actually good even for doing new modules of the existing project. I think I would argue for that. But sometimes people don't want to have two different methodologies. So a lot of times people use prompt-driven development when they first start a project or when they're migrating. And migrations are good because when they're doing something new, like a big dramatic change, they're like, okay, I'll give this PDD thing a chance, right? Yeah, so go to town with it, guys. Let me know. Like, try it out, install the PyPy, join Discord. And I don't know how many of you guys are in the Bay Area or like nearby Palo Alto, but we're going to have a user event on September 4th, and you guys are all welcome. There's pizza. We're going to give out T-shirts like this cool T-shirt, and so if you guys are around on 7 o'clock on September 4th, Thursday, please stop by.
Right.
So is this like in Meetup?
It's a meetup, yeah, it's a live meetup in Palo Alto.
Okay, so look for the PDD meetup in Palo Alto.
Palo Alto, yep. Yeah, free food, free shirts, stickers. We're gonna give you little PDD stickers that look like this. So yeah.
Cool. Maybe we can work on a crossover event. You're doing the in person.
Oh yeah.
And that'll be the next
that's a good idea. Yeah, let's try that.
What is it? September 4th. That would be the actual CalPy meetup date.
There you go.
Yeah, so we'll just get a laptop set up on your end. That'd be awesome.
Yeah, that'd be cool.
I like it. All right.
So for me, that would be a special trip, but I'm going to make it.
Okay, that's awesome. Thank you, Robert. Yeah, anyone else is welcome to join. You'll get some dinner too.
I might carpool with Robert. We'll have to see.
Okay.
Yep.
That'd be good. And tell your friends we're looking for as many people to join and get in on this new idea. So
cool. Well, hey, it's a Python package and it's in California. So send me the details and I'll put an event on the CalPy.
I will do that. Thank you so much. We have a Luma event, so I'll send you the Luma link. And yeah, if you could post it, that'd be awesome.
Cool. Sounds good.
You guys can share it with your friends. That'd be awesome too.
Great.
Right.
All right. Well, I think we have a few announcements for the next week if no one else has any other questions. Did we get to Thomas's question? Why create AI generated tests?
Oh, I didn't realize there was a chat message. I didn't even read this. Sorry.
Only just recently. It's not been too long.
Oh, okay. I thought I was missing all these messages. Okay. Why create AI generated tests for AI generated code if a code gets generated? The reason why is because it's like a safety net, right? Because inherently the prompt is a high level abstraction, so it doesn't have all the details. And so basically the methodology is this: you generate the code, and if you find a bug, you basically auto-generate, like using Cloud Code or let's say PDD, to auto-generate a test. You basically append it to the unit test file. And so these test files do get kind of long, right? So but basically make sure that when you generate it again, it still works. Essentially, it doesn't, you don't regress backwards. So it's the same reason why people would have test today is just prevent regressions. Well, okay, the second part is how does that verify that a code change hasn't caused? So we run all the unit tests again and make sure it works, and then we fix it if it doesn't. And then the prompt is the source of truth. So we look at the prompt to figure out, is it a code problem or a test problem? Or both. But good question, Thomas. Well, I hope I answered your question. I don't know. If not, unmute your mic or whatever. Oh, right. Okay, it says right, but aren't the tests getting... No, the tests are not getting regenerated. Only the code gets regenerated. Yeah, so the test you can think of almost like a log file. It just keeps growing, essentially.
Awesome. All right. Well, I think we are getting close to done here. So once again, Greg, thank you so much. Amazing stuff you got going on there. I'm really looking forward to digging around in there. I think you should keep an eye out for some pull requests from my end. I've got some ideas on just like the marketplace stuff, like simple, stupid marketing things.
Please like put issues that you find, pull requests, all that good stuff. Yeah, please.
Awesome. Great stuff. Really amazing. I'm looking forward to playing around with that. All right. Well, I will see you all next month. Thanks for coming out, people.
Thank you, guys.
Cheers.
Cheers.
Bill says good night.
So.
Good night.